Hello, my name is Mo Steiner, and today I'm going to walk with you through species distribution model with the use of different softwares. In this case, we use QGIS, ArcGIS Pro, as well as Maxent, which will then actually build the species distribution model. We're going to start very basic. Here you see all the files we are going to use. This CSV file here are our data points, our occurrences. In this case, we take squirrels in South America. I have added a few different file types to show the biggest range possible. Here we have a TIFF file of the biggest cities, which we will afterwards use to model the proximity from every squirrel occurrence to this big city. Here we have two ASC files. These are temperature averages of the whole world, basically, per month. Here we have the same thing, but instead of for temperature averages, we have it for biological indicators. And here we have a shapefile, basically, which consists of the world's protected areas. I have compiled this file myself, and it basically consists of the whole of the global protected areas. We have a lot of different file types here, and the aim is to bring all of them together, all of the shape files, TIFF files, and also with the proximity and TIFF files into an ASC file, because that is what is necessary for our species distribution model. Let's start with looking at Maxent. This is where we afterwards going to build the species distribution model. On the left side here, on the left side, you insert the samples. So in our case, I already prepared this. It's a CSV file, and it is very important in this case that this is a CSV file. First of all, it cannot be an Excel file or anything else. It must be a CSV file. And I will show you how it must be built up. So on the very left, you must have species, where you of course indicate put your species or whatever you want to model. Afterwards, on the second column must be longitude, and the third column latitude. This must be exactly like this, otherwise Maxent won't run. Therefore, just please make sure that it is built up in this way. Once you have this file ready, you can move towards the predictors. So that's all these different other files we have. I would say that because these two are already ready, they're basically, I put them there as like, this could be the outcome. So these could go straight into Maxent and can therefore run there. Just a short information, Maxent, I use the latest version I have here, which is 3.4.4, and this is used with the interface of Java. I will start to walk you through from the very basics. What we're going to do now is we're going to import some of these files into QGIS so that we kind of can see them. I would like to start. You can import it with GIS, in QGIS, however you want. I like to do it just in this way, or I can just drag them here. And so we have here now already our first two layers. These are our TIFF files. And also one very important concept of Maxent is that for every single predictor, also environmental layer called, you import in this software, Maxent, must have the same properties. So what I mean with properties is they have to have the same extent, 100% the same width, same height, same origin, and same pixel size. If also one value just differs a little bit, it won't work. Just to put it out right now. I'll start with a simple step. The extent and also the dimension which is displayed here is the one we're going to use, because the global one, which can be used for global models, and we're going to use it also for our model today. So therefore that will stay the same here. We will have to change for some others, but so therefore you will see there how it is done. The single step which we need to still to do in order to make these two files ready for Maxent is to transfer them or to transform them into ASC files. This is done quite easily in QGIS. What's basically done here, just click on the file, go to raster, conversions, translate, and then this is going to translate it. You can select CRS here. I suggest to do that. And then this does not have to be filled out. Only thing which must be done is to put the output file where we're going to save these. I'm going to save these in this file here. Let's see here. Files. Modeling. I'll put them in here, and then I will call this, because I just used this one, I'll call it Bio1. Save, and this is going to run. This might take a few seconds, shouldn't take too long, depending on the file size. If it takes longer, I will speed it up. All right, so you just have seen that. You can see that it's done. You can see here the new file. We will do the exact same thing for the Bio7 one. So just go back here from log to parameters, select Bio7. You see this is very different. And then we are going to change the output, which in this case, we can just call it like Bio7. And as you see, I selected here save as ASC file. This of course must be done in order for you to save them in ASC. You can see here you can also save them in a lot of other formats. As I told you before, we need ASC, and therefore I selected that one. Therefore that will be run again. That will run again, and whenever it's done, I'll be back. Okay, I think it will be done very, very soon. As you can see here before, the previous one took 54 seconds. This will take around the same length. There's something I would like to explain on top of this. As you can see here, this is our ASC file previously prepared, and yeah, you can see here it has been finished. Now we have both done. As you can see here, these are rasters, which means that they all have a certain pixels. And what I just showed you before with the extent and the pixel size, that correlates with the pixels you can see here. For instance, if we go here down to Antarctica, you can see this is like one of our pixels. And the pixel size, as you can see here in the properties, it shows you basically the size of this pixel, and this pixel size must correlate for every layer which is imported into Maxent afterwards. Pixel size you can see here, and that must be the same for all of them. Okay, these are our bio layers. They're now ready for importing to Maxent. Let's go back here. I would just like to copy these two because they're already ready. I just would like to copy them here so we can afterwards use them directly from this folder. Our next step is going to be that we import this file. This is basically a TIFF file, again, of the global cities. And this is what you see here is already the Euclidean distance when we're going to model afterwards in ArcGIS. We will do the same thing afterwards for the world protected areas. This is the outcome from afterwards. We will also transform this in ASC before that, and afterwards we'll move on to the last one. We will just check here real quick what the dimensions are. As you can see here, extent is correct. That's the previous one. Pixel size is also the same. As you can see here, there's statistical valid percent. Here you can see 72. This is not 100% because, as you might have noticed, looking at this, but we have some parts of the world missing, such as Antarctica. This is the problem because the data which I took to compile this file, to make this file of global cities, did not contain data from the very top of Canada and Greenland, as well as Antarctica, and some of the other islands there as well, Svalbard and Russia. Which is like an issue if you would like to model these kind of areas with species occurring in these areas and regions. However, if for our purposes today, this will be just fine. And as long as, because we only stay in South America, and as long as the pixel size and the extent basically is the same, we are all good. But just that must be confirmed that it's the same thing. So the only thing we have to do now here is again to transform it into a TIFF file, into a ESC file. Apologies. This is the same steps. This is very easy. We're just going to say global cities by Euclidean distance. That is a feature which you can see here, and that is something which is done with ArcGIS. That's the reason why I have ArcGIS open, where the program ArcGIS measures, basically it takes the point for every city which you have in your old file. As you can see here, for instance, the very dark spots are the closest to the cities. And the further away from the city you move, the distance gets always brighter, which means the distance from a city is further away. This kind of feature or analysis, the Euclidean distance analysis in ArcGIS, can be very useful for species distribution models because you can model afterwards the proximity of your occurrences to a certain environmental feature, which can be rivers, which can be roads, which can be, as I have here, cities, farms, and what we're going to model afterwards is protected regions or protected areas. As you can see here, this has been finished, the translation, and to add our last predictor, which is the protected areas. Here we have to add the shapefile first. As you can see here, this is quite a poor data set, I would say. It's a very big data set, it's 4 gigabytes. But the data itself is not the best, I would say, but it's global. I've compiled it myself. I have just I was able to download the different protected areas for every continent, and I've compiled them together as one layer at the end. You can obtain it. You can contact me in the email, which you can find in the description below, and I can provide you with the data set. I would also, in the data set and the description below, I will also mention the sources for every data set you can see, which we're going to use today. We have to wait now until all this data is loaded. It might take a bit because it's a very big data file. As I said, it's 4 gigabytes. And once it's loaded, I'll be back and I will talk about the next steps we're going to take. What we're basically going to do, we're first going to transform this into a raster, because this is right now a shapefile, which is a vector. We have to transform it into a raster. Afterwards, we have to adjust the extent and the width and the height of the whole layer, and afterwards we have to import it into ArcGIS, where we are going to run the Euclidean distance analysis, where we measure for every single pixel the distance to one of these protected areas. And afterwards we have to transform it to ESC, and then we're ready for the modeling. So while I was talking, this finished to load. Our next step is to transform this into a raster. This is very easily done here in QGIS. I would recommend to do QGIS because that's sometimes easier than ArcGIS. We're going to use this here. vector to raster. We're going to use this. Is the only vector we have, therefore it's already showing us this one. Output extend, this is an important one. We're going to use layer extend, and then we're going to use the layer extend from Bio1. This is the one that we're going to use for all our predictors, and therefore I'm choosing this one. And as you can see here, it's putting in the necessary data. Output pixel size units. We have to use georeferenced units, if I'm not mistaken. And this is all good. And then we have to use, we just have to put out the output file. First we have to do TIFF, otherwise it's not going to work. And we're calling it world save. And then we're going to run this. All right, I have forgotten to input here. We have to import, of course, the resolution, which is our pixel size. This can be very easily done by this. And because it is the same for both, we are just pasting that there. So we're going to use reference units, and here we just put this. And here we're going to use the same. Here we again doing from layer extend Bio1, as I just explained previously. And then here, this is all correct. The only thing which is missing is this. And here we're going to say this is called and this should work now. This might take a bit, first of all, because it's a pretty big file, and because it has to make the conversion. Whenever it's back, I might speed it up if it takes quite a while, and whenever it's done, I'll be back. All right, this took quite a while, as you can see here, 1,700 seconds. This is quite a bit, but now we're done. As you can see now here, this is the layer we just created. This must be, I will just try something because I think I will just try something because there might have been some issues with creating this, but I will let you know soon. All right, this just finished, but as you can see here, there were some mistakes building this because as you can see, these were not valid pixel sizes. Because like usually, otherwise you would have seen here a certain pixel size, but as you can see here, it's not valid. Therefore, I will do the same thing in ArcGIS because it should work there as well. And sometimes easier, it very depends on file you have. I'll move these two files here. One file is the one we have to put into ASC. We have to transform it into ASC. Another file is as reference. Oh, there we go. This takes now a while. This now I have to wait again until this is loaded, and then I will come back to you very soon. All right, now we're back. It's just loaded, and this looks exactly the same way as before in QGIS, a different color, but that depends how it is imported. That's randomly assigned. Now we are going to do the same thing here in ArcGIS. Just it is done a little differently from the software, but the outcome should be good afterwards. So what we're going to do is we're going to use here the geoprocessing tools, analysis tools, geoprocessing, and then we're going to do feature in QGIS and ArcGIS, and you will import this one, and then we're going to take name as field, and then output raster will be this one. 1 second. Okay, now we have to select the output raster. I will put this in the same folder as the previous one. So this should go in here. We're saying this is where protected areas. Let me save this. Here we have the cell size is. I will just keep this one and afterwards change it. I think that's better. And then we just run this. This now takes again a little bit. And afterwards, we have to change the cell size. That might have been the issue previously with the QGIS run, but this works fine as well. And I will be back whenever this is done. Process. All right, this is finished now. As you can see here, it has been created here. It's a TIFF file, and we will import it into QGIS because I'm more familiar with how it works there and how to change the extensions. I think it's easier to do it in QGIS, and then we're basically adding the file we just created, and then we can move on from there. Let's see here. This should be the one. As you can see here now, the pixels are so differently. And now we will just export this, and we just save it with a different extend, so that you can also see how that works. You basically only export it, and then here you can adjust this, and you can select calculate from layer, and we do by a 1. And also here, for the resolution, we're going to use the same as before. So everything is in line. And then we have to select the output again. And then this should work. And then there we go. This is our TIFF file. Now we have to transform this again into ASC. So we go again, raster conversions translate. This the same CRS, and then we are selecting. Here we're going to select ASC because that's what we need for Maxent. Then we run this, and something very, very crucial to understand or to mention here is that Maxent is very, very sensitive to what kind of ASC files are imported. It's not only important that you import ASC files, but as I mentioned before, they have to be same extent. And also something very crucial is that they have to contain no data value. Okay, so I can show that here. We're also going to check now if this one, the one we just created, has a no data value. Otherwise, we have to create one, because otherwise it will not work for us. This was this one we just created. We are going to open this with mEditor. That's some kind of notepad, but can be used for very large data sets as well. There was an issue. I'm just going to try it again. As you can see here, no data value, and it's here, so that's very, very good. So all these numbers you can see here, these are no data values. So we have, because you have to imagine that you have this very big layer, which is the world with this extents. So with these are the corners, and every single pixel has must have a certain number. Okay, and depending on the number, it will also be expressed differently afterwards in your map, as you can see here. But there must be a certain number which is used as no data value, which tells you that in this certain pixel there's no data, or this is, for instance, in other occasions it could be that this is the ocean, or just locations where there's no data. In our case, we were lucky, and it's already written here, no data value, and this is also something which ArcGIS usually adds to your projection. Your browser used ArcGIS afterwards to make this, to transform this into a raster, to rasterize this vector basically. If this is not present in your, whenever you open the ASC file, because ASC file is a text file basically, and you have to always to check that you have no data value. If there's no data value present on the top left, you have to add it manually. So you have to look which kind of number occurs very frequently often, which is your no data value, or you have to identify in QGIS what is your ID or number in the layer, which is not important for your current modeling process. And in our case, we're lucky, so this is our no data value, so therefore we are fine. We can close this again, so it's just a check. So this basically means now that all our layers are ready for mapping in Maxent. Therefore, we're going to Maxent now. We are making this pretty big, make it full screen. And on the left side, you can see samples. Samples basically means that we have to import here our occurrences. We just do browse, and then we're going to select our CSV file. It must be CSV, as I explained before. Otherwise, this won't work. Therefore, we have to go first to get this. Here. This is important. You can see this checked off. This is very necessary. And then here on this right-hand side, we have the environmental layers, and that's where we import all our predictors. We'll press again browse, and then we can you just navigate to the folders. We have all your predictors. They must be in the same folder, otherwise it's not going to work. We have them all in here, and then we do all files. You can see ASC files. You can see all your ASC files. You click on one of the ASC files, and then press open, and it will open all your ASC files. Something I have forgot now, which I will do now. I have not done the Euclidean distance for the world protected areas. So we have to go back to ArcGIS. We remove this one here because we do not need this no more. We have to import our TIFF file from the world protected areas, which is necessary to do this. And this is here. You can find it here. We have to import this here, and then we're going to create proximity analysis. I will show you how that works. We go to analysis again. We're going to go for raster functions, and then we go down all the way to distance, distance legacy, and then we do here Euclidean distance. Then we input here our raster, which we want to run this Euclidean distance. Barriers is not necessary. Cell size is also not necessary, but we'll just put it there just because it's handy. We will not put a maximum distance because we don't want that. And we are going to do geodisk. And then for general, we're going to put output pixel file. We're going to use 32 bits unsigned. We do create new layer. This is going to work now. It's going to run. I'm pretty sure that all my settings are correct. This is running now. As you see at the top, whenever this is done, we will see the Euclidean distance. Afterwards, this file must then be translated into ASC, and then it is ready for our Maxent model. I will be back whenever this is done here. All right, this just finished. This took again a little while, but a little bit less than on QGIS. All right, now I'm back. As you can see here, this took again a little while, but works very, very well, I think. I think this explains what it is, basically. The further away from the protected areas the brighter it gets. This is very nice, I would say. This is exactly what we need. This has been saved, and we're going to import this saved file in QGIS because I prefer to convert the files in QGIS because I think it's easier. We are taking it from here. It's here. And this is what we just created in ArcGIS. We're just going to change the properties. To check the properties, as you can see here, there's a little deviation in extent, which is this is a big problem in Maxent, as well as here. Therefore, we have to change this. We have to put this in the same dimensions as the other ones. Therefore, we do export this again, and then we use the layer extent again from by 1. So you'll see there's a little change, which is very necessary for our Maxent model. Afterwards, we are going to name this 4, and then we do OK. This is now loading. It goes pretty fast. Once this is done, just now, we have to convert this into ASC file, and then we're ready to model this in Maxent. So therefore, we go to raster, conversion, translate. It's all good like this. Just go down, we select the output file, and you can see here, this is number 4. We save, we run it. This should be pretty fast, and whenever this is done, we have all the files ready for our Maxent model, and we can perform that. While I will be waiting here, I will explain some of the Maxent settings we are going to use. As soon as this is downloaded and converted, I will have to update this because this one is the old one, we have to update the new one. However, in the meantime, we will focus on the settings here. To be most complete with the models in Maxent, we are keeping here auto features, which includes linear features, quadratic features, product features, and hinge features. There's a description under help what these features are and what they model. For our purposes, this is perfect. We're also going to check off this box, create responsive curves, so you can see statistical responsive curves. Check enough measures are important if you have very low sample size. We do not need that as our sample size is pretty large. Then we have here output file ASC, that's great. And we have to select the output directory. Just go to browse. We go in here, Maxent ready to model. This is okay. If you want to create a output directory, you can do that here. For this purposes, this is fine. And as we can see here, it has been done. It's been finished successfully. So therefore, we have to refresh our predictors, and therefore we are doing this again. All layers. Select the ASC layer. As you can see here, now is one more. This is the old one. We're going to unselect that one, and then we have all of them ready. Now, this is all so far. We are going to run this now, and all the settings are as they should be. And if it does not work, you will get an error very, very, very soon, within the first few seconds usually. And so, because until now I did not receive any errors. I'm pretty sure everything is fine. If all the things I mentioned have been respected during creating this model, I'm sure that there should not be any issue with the model itself in Maxent. There are a few things which I would still like to explain while this is running. There are a few issues I've encountered which I would like to mention here and how to solve them. One issue is if there are too many predictors, so there are too many environmental layers. That can be an issue because Java cannot handle this kind of size. I'm talking about over 120 layers of 110 predictors on the right-hand side, so environmental layers, with some of them pretty big ones. So I would say do the minimum you have to do, but still to make the maximum of a great model. So if you don't need any layer, like if you don't need some of the layers, just put them away. It will go faster in the model itself, and also Java can handle it better. Other than that, if you would like to have a very, very high number of predictors or environmental layers, you can do that. However, then you have to remove some of the features on the bottom left side, which then decreases the accuracy of your model, which I would not recommend. On top of that, there are a few errors I've ran into, which can be avoided with the things I mentioned before. So just to summarize, the samples here, the occurrences, must be in CSV and must follow the exact same outline as I've shown before, otherwise it won't work. On the right-hand side of the environmental layers, they all must be in ASCII files. They all must have the same extent, the same pixel resolution, and the same width and length. They all must contain a no data value. The no data value must, of course, not be the same, but they all must contain one. This is very crucial. This can be done with very different kind of data. It's very often done for species distribution models, but it can also be done for other kind of models. If there are any further questions afterwards, like I will now wait until this is finished in Maxent, and then I will show you the outcome. And with that, I would like to conclude the video afterwards. And if there are any further questions, or you ran into issues while looking at the video, or you have any kind of remarks, I will put my email address in the comments, which when you can write me an email and confront me with your issue, and I might be able to help you. And yeah, this is a very wide spectrum of things which you can do in Maxent, or generally in GIS, combining with Maxent, with Euclidean distance, and with different kind of file types. And I have tried to include all this in this video, and I hope you liked it. And yeah, I will be back whenever this has finished. I'm very sure it's very soon, but I will be back then. All right, just a couple minutes later, it has finished. Maxent does not give you any kind of confirmation that it's finished. Just stop loading, but it has finished successfully. There was no errors. We can see the output now. What we have created. We're going to display this in QGIS because I'm personally quite a big fan of QGIS, and it's simpler in my opinion. Let's see what the outcome is. You can see the outcome here. So the ones I just highlighted, these are the outcomes. So the most important files are the ASCII file, which we'll have a look at it soon, and the HTML file. We're going to first look at the HTML file. This HTML file displays you an online version of the model, of the outcome of the model, and this is what you can see here. Here, of course, with the omission, the more predictors you have, and also the more occurrences you have, the more accurate it is. That's basically it. From this first graph, a few very important things. The most important things here is the picture of the model, which you can get kind of an impression what's the outcome of the model. You should be able to see this bigger. Yes, indeed, like this. So basically, what you can see here, we will also look at it later in QGIS, but here it's already with colors, makes it a little bit easier. On the left-hand side, you can see the occurrences scale. Of course, 1 means it's very, very likely it occurs there, and 0, there's very unlikely it occurs there, the species. I would just like to mention that I only used a very few amount of predictors, so it might not be the most accurate model, but for these purposes, it was all right. Otherwise, it would have taken longer even. The white cubes here, these are the actual presence points, which we imported into Maxent. And as you can see here, based on our predictors, there are other very, very similar regions. in South America and in Africa, where this species would be very, very likely to occur. For instance, here in Brazil, and then here around the equator in Africa. What we can conclude from this is that if this species would not be limited to these kind of regions, it could very likely to occur in this part of Brazil here and in around the equator in Africa, and also parts of Papua New Guinea. Could be a possibility to find some species if it would not be locked to this region of South America. This could have a very great implication. For instance, if there would be some kind of relocation of the species to avoid extinction or different possibilities. We conclude from this map, which has been created for us from Maxent, and here there are some responsive curves which we check the box. Here you can see the analysis of variables, so you can see how important the different variables are in our model. So like the higher the percentage here and the permutation importance means that it has been identified from the model, from the software actually, that this is the indicator or the predictor which predicts the occurrence in the best way possible. And the higher it is, the better it predicts the occurrence. And this is displayed here. So we can see that Bio7 and here the world predicted areas and temperature average 1 are one of the most important predictors here. And there's like some other information which can be accessed. This is one thing, is the HTML file, and then we can also look at the ASC file, which is here. We can just import it into QGIS, and we can see what it will show us. Whenever this will be saved, I would suggest you to set a CRS first, because it doesn't set one automatically, but that's okay, it doesn't really matter. Now it's set. And this is the same as you have seen previously here in the HTML file. This is the same, just without colors, and this can be saved as ASC file. This is saved as ASC file, can be converted into TIFF file, and can be saved as such. It's quite a big file, so it takes a bit to load, but it tells you the same thing as the one previously seen in HTML. And here again, the brighter the spots, the more likely it is to observe the species. And with this, I would like to conclude the video. As I mentioned before, if there are any comments or issues you run into, I will leave my email address in the description below, so you can write me an email, or you can also just write in the comments. I will check them regularly. And yeah, I hope I helped you. And yeah, I hope you have a great rest of your day. Thank you very much.